This is the Low 6 Key Assessment 3 on the core, and this is paper number 1, and this is the help me video, which is not going to give you the answers, but try and help you. This question is about immobilized enzymes. Mentions enzymes and immobilized. So with any enzyme question, you are trying to figure out what the substrate is, what the enzyme is, and what the product is, and that will help you suss out what's going on. And pectinases are enzymes. So that's our enzyme there. Apple pulp is added at the top, and that is pectin is what's holding these together. And we're trying to break those down. So our substrate is pectin, and our product is the juice collected at the bottom. So the juice, that's our product. Okay. And if we slow this down, well, we're only going to get a reaction where a substrate is in contact with the enzyme and get a collision. So if we slow this down, then that might happen a bit more. You just need to explain that. Explain part 2. Why higher yield of juice, so you get more product was attained when using free enzymes rather than, hang on, there we are, I'm looking at the wrong question. Graph. 3 lines on a graph. What's the graph of? We have got temperature increasing, and this is the volume of juice there. So this is our product. And we've got 3 lines on here. Using the graph, so using a graph and your knowledge, using the graph, we're going to have to do that. Your own knowledge of enzymes, yeah, AO1. And what do we need to do? We need to describe and explain the results for the free enzymes. Free enzymes. So, which one is the free enzyme? It's that one. So that one, what happens to it? Describe it. So temperature of 20. But we don't need that. Above 40. So the free one above 40. There's 40. What happens to it? It does this, then it does that. So it does that down to this level, then not much else. So there's 2 marks there for saying what happens, and then the explanation is why is this down there at 0? What's gone on? Using your knowledge of enzymes. Over to page part 2, why the higher yield of juice was obtained when using free enzymes rather than immobilized enzymes. Right, so there's the free, and these other 2 are immobilized. What did they do? We have got enzymes bound to the surface of a gel membrane. So we might have a membrane with the enzymes on. So that might be that one. what's the other one? Inside alginate beads. So we'll use blue for that. Inside alginate beads. So our enzyme is inside there. So beads, membrane, and our free enzyme, which is free enzyme there. And they're asking us why you get more yield when using the free enzyme, so between 20 and 40. So they are asking us between 20 and 40 here, so this part of the graph, why is that higher than these other two? Why, when we use this free enzyme here, you get more juice, more product than these? So you've got to think of the substrate, so our substrate, which might be around here, it's got to collide with our enzyme active site, and it's going to be easier with our free enzyme to collide rather than our membrane. Well, some of it's attached to the membrane, so it might not be available. And with our beads, it's actually got to get through the alginate beads to get to the enzyme diffusing. So it's easier to use the free enzyme. Part 3, explain the differences for the enzymes bound to the gel membrane surface with those immobilized inside the bead. Explain the difference between the gel membrane ones. The gel membrane, what colour do we have those? So the gel membrane ones with the bead ones between 20 and 60. So between 20 and 60 we're comparing the membrane one, which is triangles, with the bead ones, which is the squares. So the first thing we notice is the membrane ones have a higher yield, higher volume than the bead one, and the explanation is that there's more kind of contact between the substrate and the enzyme. So this free one was the highest because these can move about and collide, more chance of a collision because they're moving and they're not fixed on or inside something. And between these two, well, the membrane one, there's more chance of a collision rather than the substrate diffusing into the beads. And if you wanted to increase the yield of apple juice, what would you do? What would you do? 4 marks, quite a lot for this. Where on this graph are we getting the most apple juice being produced? And the answer is there. So that's where we get. So we're going to suggest those. I'm going to suggest whichever line, whichever method this is, I'm going to suggest that. Whatever the temperature is there, I'm going to suggest that, because I'm going to say it's higher than these other ones. But I'm going to say which one it is. And I could come up with a couple of other suggestions. So if that's my membrane there, how would I get a higher yield? So what would I do with a membrane? I've just drawn one there. Well, what would I do to get higher yield? Possibly have more of them, more surface area of them. And we could go back to our original question and go, this would increase the yield. It told us how to increase the yield. I'm going to remember that and suggest that as well. And then that's 14 marks.